All right, hi. Um, the purpose of today's video is to show uh, or develop a formula for an annuity that has payments that are increasing in arithmetic. Um, they're increasing arithmetically. In other words, you have an annuity where you start with a certain amount, then you get another amount over that. Like, for example, let's say you get $1,000 for the first period, then you get 1,000 plus 100 for the second, and 1,000 plus 200 for the third, and so forth. And the background necessary to understand this is you should know what a basic annuity is, annuity immediate, annuity due. You should know what annuity certain is. You should be familiar with the discount factor. So let's get started. And of course, compound interest, that goes without saying. So here we go. Um, so this is a case here. So we're going to, first of all, we're going to develop a formula for this. For I annuity immediate over a period n, in the assumption you have compound interest, where the interest rate is I per period. Standard compound interest here. Now, we want to develop what this is. Now, first of all, I should explain what this is here. This, of course, is annuity immediate. Notice the lack of two dots. And the way, if you want to write this out longhand, it starts off with a payment at time one, which discounted by 1 unit. So that's going to be V, where recall that V is the discount factor, where I is the interest rate. Then you get 2. V squared means that you increase, let's say, $1 at time 1, $2 at time 2, $3 at time 3, $4 at time 4, and so forth, all the way up to n dollars at time n. Now, to get a formula for this, I'm going to develop a very specific one, and it's going to look a little clumsy at first. There is a slick way of dealing with this that we will get to at the end, and I'll leave the development of the slick way of finding a formula for this as an exercise. Now, how I'm going to actually write this out is I want to write this out as V. Then I'm going to just take a V squared from this one. I'm going to take a V cubed from this one. I'm going to take a V fourth from this one, all the way out to a Vn. So I'll put a little ellipsis here. Now look at what's left over, and I'll put that in a different color. This one is used. We have an extra V squared left over. We have 2 V cubes left over. We have 2 V cubes, 3 V4s left over. And we finally have n minus 1 Vn's left over. Now, this looks like a very, very clumsy way of doing this, but please bear with me. There is a reason I'm splitting it up like this that we will see in a second. Now, this part right here should be familiar to you if you're watching this video, because the student who is familiar with annuity immediate, and of course you should be if you're watching this, this is just annuity immediate here. Now the fun is going to start in this part. Now notice we have V squared, V cubed, etc. Now what I'm going to do is I'm going to take the liberty of factoring out a V squared. What I'm left with a 1 plus 2V plus 3V squared. And the very last one, we have n minus 1, I factored this. And notice this is 1 unit greater than this. So that's n minus 2. Let's see, yeah, 2v squared, right, v squared out of there, 2v, 3v squared, etc. So remember this number here is going to be 1 greater than this. Now, I'm assuming you've had a little bit of calculus. Now, if you haven't had any calculus, well, this probably would have been a bad video for you. But does this look like anything? I'll let you think about this for a second. See this pattern here? Well, we have 2v. That should be familiar, especially a student who's done integrals. If you're integrating these, right? Notice this is going to be the derivative with respect to v of v plus v squared plus v cubed plus v to the n minus 1. Okay? I think that's kind of interesting here. We have that. Now, that is going to be the derivative of something. And I'm going to do something with this. Now, it looks like I'm stalling, but I think it's worthwhile to keep this. The v squared is then the same. But what I'm going to do here is I'm going to factor out one more v. And look what I have here. I have a 1 plus v squared plus v n minus 2. Now, it looks like I'm doing a whole lot of unnecessary manipulation, but if you remember the summation formulas, as you should, remember that 1 plus x squared plus x to the n is 1 minus x to the n plus 1 divided by 1 minus x, provided x is not equal to 1. Now, the discount factor is equal to 1, then interest rate is 0, and, well, it's kind of becomes a very different exercise. We're not going to worry about that. So we're going to assume that the discount factor is not 1. That's not a bad assumption. We have now d dv v. This part right here is now 1 minus v n minus 1 divided by 1 minus v. Okay, we're almost ready to do some math here, because now that we wrote this in this nice, concise manner, we're almost ready to take the derivative. And I'll just write this v squared there. I'm going to now distribute the v. You could, I guess, if you're a glutton for punishment, use the product rule for derivatives, but I'm not going to. So I'm going to write this as v minus v the n divided by 1 minus v. And there you go. That's something we were going to do. We're going to use the product rule. I mean, not product rule, the quotient rule for. So this is a to n plus v squared. Now let's just to differentiate this. And if you remember the the quotient rule, the denominator gets squared. Then you take the derivative at the top. That's going to be 1 minus n v n minus 1 times the bottom minus, well, the derivative of the denominator is just negative 1, v minus vn. So we calculated this derivative, and let's just get rid of this. Let's get rid of the denominator like so. Now let's do a little bit of algebra. 1 times 1 is 1 minus n vn minus 1 minus v plus n v the n. And all this does is flip the sign. So minus a minus, this becomes a plus v minus vn. Okay, that doesn't look too bad. Now let's do a little bit of algebra here. I know some people don't like to cancel this, but I call it cancellation. Deal with it. We have that. Now you notice you have this 1 and you have this minus Vn, so let's just deal with that. And we'll just keep this. Now we're going to end up doing something with this factor here. We'll be doing something with this pretty soon. What I'm going to do is I'm going to take this 1, I'm going to take away this v sub n, v to the nth power. So I've accounted for that. And then I have this part right here. I'm going to add, I have this n vn minus n vn minus 1. Okay, so far so good, I guess. Now, let's go ahead and continue on here. And I will be doing something with this. Now, if it looks like I'm waffling here, there's a reason for it. Yes, I just squared that out. I now have a 1 minus v sub n. I'm going to do this. Then I'm going to do this in a different color here. I'm going to factor out, I'm going to go ahead and write this n here. So I'm going to add n. And then I'm going to just go ahead and write this as vn minus vn minus 1. Might be a extra step you don't need. That's all right. Because we're almost done, believe it or not. And now we have this that we want to isolate. I'm going to take a v to the n minus 1 out. And when I do that, what do I have left over? I have an extra v here, and I have a minus 1. Now we're ready for the punchline. What I'm going to do next is I'm going to multiply this factor and distribute it in this factor here. I got a little sloppy with the colors, but that's all right. Okay, we got that. Now let's multiply through. Up top, we have a v. We have a 1 minus vn over 1 minus v. That's cool. Then we add. We have an n. This v times v to the n minus 1 is nv right to the nth power. Then I have a v minus 1 divided by 1 minus v. Look what happens there. Aha! What happens there is this. Now we're ready. Let's just take a look at this part here. This part, we'll play around with it in just a second, but that's gonna be nice. Let's look at this part here. Anybody recognize this? This part here, that's the present value of an annuity immediate of length n. This part, the 1 minus v sub n and 1 minus v, that's annuity due. Annuity due discounted by 1 unit is annuity immediate. So that's what that is. Now, this part right here, that's just negative 1. And then finally, this little thing here, and I'm sure you know this if you're watching this video, this little thing right here, that's 1 over 1 plus I, 1 minus 1 over 1 plus I. Then if you multiply top by 1 plus I, and the denominator by 1 plus I, you'll see that's just going to be 1 over I, right? So we get the following formula. We get the following formula that IAN is annuity immediate plus 1 over I, and that's an important formula for financial math. But we're not quite done yet. I mean, we're done with that part, but we still got a little more to go, a little bit more to go to make this general. Now let's take a look at what we did. We started with this, okay? And I broke it up like this just to, on purpose, to show you a couple things here. Now this is a case where you start with your basic annuity immediate, and then starting at time 2, you add 1. Well, what if we had the following? Suppose instead of this, where we started with this and added this here, suppose now we had the following. Suppose what we wanted to deal with was this. Suppose we wanted to deal with P times V plus, let's say now, P plus Q times V squared plus P plus Q times 2 V cubed all the way out to P plus n minus 1 Q V n. So what this annuity deals with is you start where the first payment is P at time, this is at time 1 because it's annuity immediate. First payment is P, second payment is P plus Q, third payment is P plus 2Q, and so on. So you keep adding multiples of Q. That's called arithmetic progression. Now look at this thing here and look at how we broke this up. If you took a P here and you added a Q here, what this is, and I'll just go ahead just to emphasize this, and I screwed that up, darn it. But I'll just write this. Well, I do want to utilize a cut and paste just because. Copy. And this is not going to be great here. But if you take a look at this and you say, all right, you take a look at this part here, this is going to be your base amount P. And then you're going to, let's say, do Q times this amount. This is sometimes denoted by I. And I have to get this right here. P, Q, and A, angle N, is how it's often denoted, where P being the base amount, and you add multiples of Q. So for example, if you had an annuity that started off with 100, and then you had 150, then you had 200, and so forth, here P would be 100, and your Q would be 50. So this would be 2 times 50, 3 times 50, and so forth. So that's what this is here. Well, look at what we have. Look at our development. This did not change, and this Q is multiplied by all of these terms, so it could be factored out. So we can keep the Q here. So what we actually showed is that we can modify this formula here, and I'm going to try to select it better. Copy. And let's paste it on. And so I'll go ahead and slide that here. So what we can say is that this I, P, Q, A, angle N could be P, and then we could just erase this and just do this. And there you have the this formula here. Now, there's a couple of little items I'd like to finish up with. So this is a basic formula for arithmetic increase. Now, so a couple of modifications, and then I'll give you an exercise. So now suppose you would like to do, instead of the present value, let's say we want to do the future value. And again, keeping it as annuity immediate. Well, all you really need to do is you just need to multiply this whole thing by 1 plus I to the nth power. Well, if you distribute that, this is, of course, pretty easy. That's S, future value. This QI, or this thing, remains the same. When you distribute this here, that just becomes S sub n. Now, what this V sub n here, remember, is one. Remember, V sub n is just this. So when you multiply it by 1 plus in, you're pushing the value into the future. So this just mainly just becomes an n right here, and that's the formula that we have in this text. So it's not a big deal there, right? So that's the first thing, first modification. The second modification I'd like to do is, if we want to look at annuity due, well, remember, annuity due, the difference is that we remember the key formula here. If you take this, remember that the first payment starts at 1, right? So the way you do that, all that is you take annuity immediate. So this starts at V and you divide by V, right? And so, because remember annuity immediate starts with V plus V squared plus a dot. So if you divide by V, that's what you get here. So if you do this, it's going to be 1 over V and this is, again, not too bad, because that becomes, right? So yeah, just remember, all you're doing is dividing by B, or you're multiplying by 1 plus I. And that's what we're doing here. And then the thing is, this is going to be minus n V to the n minus 1. Okay? So that gives you the formula for annuity immediate here. And let's see, there's one more thing I want to do in this thing. Yep. Yep. And I mean, you can also modify it in a different way. The other thing I want to do is I want to start with this again, and here's an exercise. Now, some textbooks leave this as annuity immediate there, and what you end up doing is you turn this into discount, but that's okay. This thing here works nice. All right. So next I want to show this exercise here, the exercise here, and derive the following formula. And this is going to look a little bit different, but and we're going to get this minus NVN from first principles. And the way I would, what I mean by first principles is that if you write this thing out like so, and if you factor out a v, you get 1 plus 2v plus 3v squared plus nvn minus 1, we end up with this is going to be the derivative of v plus v squared plus v cubed plus vn. And this is this part right here. And I'm not going to do the whole thing, but this is a good start. We now have a v here. And we now have a 1 plus v squared plus, you can see this is annuity due. And then to finish this up, you use the sum to write this. Use the product rule and get this directly. Now you can take this formula that we have here and obtain this, directly by just doing a switch, but it's more fun to try it this way. So that's what I wanted to do with this, and thanks for watching.